January 1943. A cold wind sweeps across a British airfield in Lincolnshire. The ground is frozen solid, the sky pale and colorless, the kind of morning that numbs the hands and stiffens the breath. Yet, a small team of Royal Engineers moves with quiet precision. Sheets of corrugated steel arc into place, each section locking perfectly with the next. Bolts tighten, the curve takes shape, and by noon, a complete Nissen hut stands. A shelter born of necessity, speed, and wartime ingenuity. A few hundred yards away, American Seabees are at work. Crates are cracked open, blueprints unrolled. The new Quonset hut, America's answer to the British design, looks similar from afar, but its pieces are heavier, its frame more complex. Assembly takes time. The men struggle against the wind, improvising tools and cursing misaligned panels. By dusk, the difference is visible. One hut already shelters men and equipment from the bitter cold. The other still lies half-finished. The story of the Quonset hut begins long before the United States entered the war. It begins in the mud of the Western Front during the First World War. In 1916, a Canadian-born British officer named Major Peter Norman Nissen found himself studying a problem few soldiers had time to consider: shelter. The British Army was expanding faster than it could house its men. Canvas tents were cold, temporary, and easily destroyed by artillery blasts. Brick or timber buildings took too long to build and were impossible to move. What the Army needed was something simple, strong, and portable. Nissen was an engineer before he was a soldier. He had worked with mining structures in North America, and his mind returned to those curved, self-supporting arches of steel. Within months, he designed a semicircular hut made from corrugated iron sheets bolted to a simple steel frame. The shape was elegant and efficient, no wasted material, no corners to trap heat or weaken the structure. The curved design deflected wind, shed rain, and could be assembled by 6 men in a matter of hours. By late 1916, the British War Office approved the design. Factories across Britain began producing the new Nissen hut, named after its inventor. More than 100,000 were built before the war ended. They served as barracks, mess halls, hospitals, and storage depots, light enough to transport, durable enough to last through bombardment, and cheap enough to produce in bulk. After the armistice, the huts spread far beyond the battlefields of France. They were shipped to colonies, airfields, and ports across the British Empire. During the interwar years, the Nissen hut became a quiet symbol of British practicality, adaptable, economical, and unpretentious. Rural communities turned surplus huts into garages, workshops, and classrooms. Even as the empire tightened its belt during the 1930s, the Nissen hut remained in service, refined with new materials, simplified connections, and better insulation. By the time war returned in 1939, Britain already had a tried and tested system for quickly building temporary camps and depots. The Nissen hut, once a battlefield experiment, had become an essential military tool, a structure that could follow the British Army wherever it went. And when the war began to engulf the world once again, another nation, vast, industrial, and newly mobilized, looked across the Atlantic and took notice. By 1941, the United States faced a logistical crisis on a scale no nation had ever encountered. The country was not yet fully at war, but the machinery of mobilization was already roaring. The U.S. Navy, preparing for operations across 2 oceans, needed instant infrastructure: barracks, hospitals, mess halls, offices, all portable, durable, and capable of being shipped thousands of miles. Traditional wooden construction was far too slow. Concrete was impractical. The Navy Bureau of Yards and Docks searched for an alternative, something fast, simple, and universal. Their answer came not from invention, but from adaptation. At Davisville, Rhode Island, engineers began studying Britain's wartime shelters. The Nissen hut's curved design impressed them. Efficient, modular, and easy to mass-produce. But American manufacturers wanted to modify it, to use American materials, standardized measurements, and U.S. industrial tooling. The result would be called the Quonset hut, named after the site of its birth, Quonset Point Naval Air Station. In early 1941, the first prototypes rolled out. They kept the familiar half-cylinder shape, but replaced the Nissen's narrow steel ribs with broader, corrugated panels attached to a wooden frame. Plywood end walls and flexible insulation made it easier to adjust for different climates. Each hut arrived at the front as a complete kit, about 10,000 individual parts packed into crates, ready to be bolted together anywhere on Earth. When America entered the war after Pearl Harbor, the Quonset hut became a symbol of its industrial might. Factories in the Midwest and East Coast churned them out by the tens of thousands. Within months, U.S. forces were erecting them in Iceland's frozen fields, the deserts of North Africa, the jungles of Guadalcanal, and the islands of the Pacific. The design was not perfect, but it was fast to manufacture and easy to transport. Exactly what the Navy needed. Engineers revised it constantly. The early T-rib model gave way to the strand steel frame, improving strength and reducing weight. By 1943, more than 150,000 Quonset huts were in use, providing shelter for men and machines across every theater of war. But beneath the surface of American triumph lay a quiet irony. The Nissen hut had been created through years of battlefield refinement, a soldier's design for soldiers' needs. The Quonset hut, by contrast, was born in boardrooms and shipyards, a product of industrial urgency rather than field experience. At first glance, the Nissen hut and the Quonset hut seemed nearly identical. Both half-cylindrical, both made from corrugated metal, both designed to shelter men and machines from the elements. Yet, beneath their curved silhouettes lay two very different engineering philosophies. The Nissen hut was simplicity distilled to its essence. Its arched ribs were made from lightweight pressed steel segments bolted together in 3 repeating panels. Each panel supported the next, distributing weight evenly along the curve. No need for heavy internal framing or excess material. The walls and roof were one continuous surface, a self-supporting shell. Corrugated iron provided both strength and flexibility, bending slightly under pressure rather than cracking. The entire structure rested on a simple concrete or wooden base, adaptable to any terrain. The Quonset hut, by contrast, reflected America's industrial confidence and its complexity. Instead of narrow steel ribs, it used wide galvanized steel panels with deeper corrugations and a wooden framework that required more precision during assembly. The Americans sought standardization. Every nut, bolt, and panel pre-measured for production efficiency. But this precision came at a price. The hut's weight nearly doubled that of the Nissen model, and its construction required more men, more tools, and more coordination. Thermally, both designs struggled. Metal walls absorbed heat by day and radiated cold by night. In Britain's damp climate, condensation was constant. The sound of dripping water often accompanied soldiers' sleep. The Quonset design attempted to fix this with insulating fiberboard and air vents, but tropical environments turned these fibers moldy and brittle. In Arctic bases, they froze solid. Logistically, the difference became starker. A standard Nissen hut kit could be loaded on a single truck and erected by 6 men in under 4 hours, using only spanners and manual labor. It required no specialized tools. Its curved sheets were small enough for one man to carry, and damaged parts could be replaced individually. The Quonset hut, meanwhile, arrived in bulky crates weighing over 5 tons. It took a team of 10 to 12 men and at least 1 full day to complete. The panels were longer, heavier, and required a level surface for alignment. In mud or sand, assembly became a challenge. While American logistics ensured that supplies were plentiful, time in the field was not. And every extra hour spent constructing shelter meant less time spent fortifying or fighting. In engineering terms, the Quonset hut was a triumph of mass production. But in the language of war, where speed, portability, and endurance define success, the Nissen hut remained the smarter, leaner machine inside these curved walls. The difference between British and American thinking could be felt, not just measured. For British soldiers, the Nissen hut was a familiar, unglamorous companion. It wasn't comfortable, far from it, but it worked. Its compact shape trapped warmth efficiently, and its simplicity meant repairs could be made with whatever scrap materials were available. Soldiers lined the interiors with canvas, newspaper, or even cardboard to fight dampness. Coal stoves glowed at the center, their smoke curling through crude chimneys. It wasn't luxury, but it was reliable shelter in a world of chaos. The Nissen hut became part of the landscape, seen on every British base from North Africa to the Arctic. Its very plainness became its virtue, a reminder that in war, practicality always outweighed perfection. The Quonset hut, on the other hand, reflected America's scale and ambition. It was bigger, wider, and often equipped with plywood floors, electric wiring, and insulation panels. When new, it looked modern, almost civilized compared to a tent. But comfort proved inconsistent. In the tropics, heat turned the metal shell into an oven. In colder regions, frost collected on the ceiling, melting into puddles by morning. The huts echoed with every footstep and amplified the pounding of rain. Many servicemen joked that you could tell the weather simply by listening to the roof. Yet the Quonset became more than shelter. It was a symbol of American mobility, proof that the U.S. could build a functioning city wherever its troops landed. Rows of Quonsets formed hospitals, command posts, chapels, and entire air bases. They stood as monuments to the country's industrial energy, each one stamped with the promise of mass production. The Nissen hut, by contrast, represented British pragmatism, modest, efficient, and shaped by direct battlefield experience. It was the engineer's answer to necessity, born from mud and artillery, not from boardroom planning. Its genius lay in what it didn't require. No heavy equipment, no excess parts, no illusions of comfort. Both designs embodied the spirit of their nations. The British driven by endurance, the Americans by ambition. Each reflected its maker's worldview. By 1942, the Quonset hut was everywhere the American flag flew. From the frozen tundra of Iceland to the blistering sands of North Africa, its curved shell rose in neat rows across every new base the U.S. Navy built. It was the symbol of rapid American expansion, an army and navy that could plant a city overnight. But the further these huts traveled from Rhode Island's temperate climate, the more their weaknesses became visible. In North Africa, the desert sun turned each hut into a furnace. Corrugated steel walls trapped heat like an oven, pushing internal temperatures beyond endurance. Insulating fiber boards, meant to moderate conditions, disintegrated in the dry air. Soldiers improvised by cutting holes for ventilation or covering the roofs with sandbags, but the structure's very design fought against them. The same curved metal that made the hut strong also made it inescapably hot. In the Pacific, another problem appeared. The monsoon rains poured relentlessly over the islands of the Solomons and New Guinea, and the huts leaked. Moisture gathered between panels, warping wooden end walls and breeding mold in insulation layers. Humidity corroded bolts and frames, while tropical termites devoured the plywood components. Ventilation systems clogged with salt air, and steel panels rusted in months. Many huts became uninhabitable, forcing troops to rebuild or move repeatedly. Even transport logistics, once the hut's selling point, began to show strain. Each kit weighed several tons and required multiple trucks or cargo holds to move. In forward areas with poor infrastructure, Offloading the crates was a mission of its own. Assembly, though technically simple, demanded manpower. Men who could have been repairing vehicles, unloading ammunition, or constructing fortifications. British observers who encountered the Quonset hut abroad noticed its shortcomings quickly. The Americans had copied the Nissen shape, but not its proportions or its philosophy. The Quonset's broader curve, intended to create more interior space, made it less stable and more prone to weathering. The British design, by contrast, was narrower, lower, and inherently stronger, a product of engineering tuned to real conditions. In reports from 1943 and 1944, U.S. field engineers acknowledged the flaws. Ventilation was inadequate, the interiors overheated, and transport costs were high. By 1945, dozens of design variations existed as the Navy sought a solution. Quonset redesigns numbered into the hundreds, but the more they changed it, the further it drifted from the efficiency that had inspired it. The Americans had built a global icon of industry, but not the soldiers' shelter they had intended. While the Quonset hut struggled under the weight of varied climates and logistics, the Nissen hut quietly continued to prove its worth. Across Britain's far-flung outposts, from the rain-soaked fields of England to the burning sands of Egypt, it remained a constant, uncomplaining ally. Its secret was not in power or size, but in proportion and restraint. The Nissen's narrower arc deflected wind more efficiently and kept heat where it was needed. Its lightweight steel ribs could be replaced on-site if damaged, and spare panels fit easily into supply trucks. Troops in North Africa built them atop stone foundations to beat the heat, while those in Northern Europe lined them with felt and timber to hold warmth. Everywhere it went, the same basic kit adapted to every climate. Proof of an engineer's deep understanding of wartime conditions. When Allied forces pushed across Europe after D-Day, Nissen huts followed within days. They became temporary headquarters, workshops, and field hospitals, springing up beside bombed villages and along airstrips carved from farmland. British and Commonwealth engineers could assemble a dozen in a single day, a rhythm that kept pace with the advance of war. Even when enemy fire damaged a hut, its curved shell absorbed impact better than straight-walled timber buildings, often remaining usable after nearby structures had collapsed. American units occasionally inherited abandoned British camps and took note. Reports from U.S. Army engineers in France and Italy remarked that Nissen huts weathered better and erected faster than their Quonset counterparts. A few even reused them outright rather than unpack new kits. The Nissen's post-battle flexibility became legendary. After a site was cleared, the huts could be dismantled, stacked, and moved again, often re-erected in a new theater within a week. The same steel that endured bombardment could endure another war. It was not glamorous, but it was timeless engineering. By 1945, as the Allies prepared for victory, the contrast was undeniable. The Quonset hut had filled the world's land. When peace returned in 1945, the world faced a new kind of emergency, a housing crisis. Cities lay in ruins, populations displaced, and returning servicemen needed roofs over their heads. What had begun as wartime necessity now became peacetime opportunity. And no structure was more abundant or more adaptable than the Quonset hut. The United States alone had produced over 150,000 of them by the war's end. Millions more stood in storage yards or scattered across former military bases worldwide. Their corrugated steel shells and modular construction made them easy to repurpose. In the ashes of Europe and the expanding suburbs of America, Quonset huts became the foundation of temporary living and, in some cases, permanent communities. From London to Los Angeles, they became post-war icons. Universities such as Harvard, Brown, and Stanford converted them into student housing and laboratories. In newly formed suburbs, veterans' families turned surplus huts into small homes, complete with gardens and makeshift porches. For many, The curved walls symbolized a bridge between war and recovery, a reminder of both endurance and industrial might. But the Quonset's simplicity also revealed its limits. Designed for speed and standardization, not comfort, the huts often suffered from condensation, temperature swings, and poor ventilation. Still, they met the urgent demand for space in a world rebuilding from rubble. Governments sold them cheaply. Entrepreneurs converted them into workshops, diners, garages, and churches. The United Nations even deployed them as emergency shelters for refugees across Europe and Asia. By the 1950s, Quonset huts had taken on an almost mythic character, symbols of American ingenuity and post-war optimism. Magazines featured them as homes of the future, promoting their adaptability and low cost. Yet, as economic prosperity returned, the same qualities that once made them essential began to date them. Suburban America moved toward permanence: brick walls, tiled roofs, and picket fences. The Quonset hut, born of war and urgency, slowly retreated to the margins, surviving mostly as rural sheds, workshops, or nostalgic relics on forgotten airfields. And yet, for a brief moment, it embodied a nation's transition, from industrial mobilization to peace, from soldier's shelter to family home. The Quonset hut's legacy was not elegance, but expedience, a reflection of the era that built it. Vast, efficient, and determined to rebuild the world at any cost. While the Quonset hut became an American post-war symbol of abundance, the Nissen hut lived on through a quieter, steadier endurance. Across the Commonwealth, from the windswept fields of Britain to the farms of New Zealand and the mines of Africa, Nissen huts never truly disappeared. They evolved. In Britain, thousands of surplus huts were bought at auctions for a few pounds each. Farmers transformed them into grain stores, workshops, and milking sheds. Rural councils repurposed them into temporary schools and community halls. Their lightweight design and modularity meant they could be moved, expanded, or repaired with minimal tools. While American Quonsets were scrapped for steel or left to rust, Nissen huts were still working, still useful. Architects studied them, too. The Nissen's semicircular efficiency, a self-supporting curve needing no internal pillars, inspired generations of minimalist and sustainable design. The concept reappeared in post-war prefabricated housing, and decades later, in disaster relief shelters and even eco-architecture, where efficiency and reusability mattered more than luxury. For former soldiers, the sight of a Nissen hut often stirred memory. It spoke of endurance, of improvised life in war zones from Tobruk to Burma, but it also represented a form of design purity, an idea perfected under pressure. Peter Nissen's invention, built on logic and necessity, required no mass marketing, no industrial overhaul. It was pure function, and that simplicity became its immortality. In the post-war decades, Commonwealth engineers and planners reused the Nissen concept for everything from army barracks in Malaysia to aid stations in Kenya. Even today, some original huts still stand, weathered, patched with new sheets of metal, yet structurally sound. They are relics of utility that outlasted fashion and excess. What separated the two designs, the Quonset and the Nissen, was not material or form, but philosophy. The British built for practicality. Quick to erect? In the great machinery of war, invention often runs faster than reflection. Factories roar, blueprints multiply, and nations chase efficiency through production rather than thought. Yet, history's quietest lessons often come from the simplest forms. The story of the Nissen and Quonset huts is not merely about steel and structure. It is about philosophy under pressure. The British Nissen hut, born from the mud of the Western Front, was guided by necessity and refined through restraint. It understood the soldier's need for shelter, the commander's need for speed, and the engineer's need for economy. It was, in its essence, human. The Quonset hut, though impressive in scale, carried the weight of industrial ambition, a product of America's vast manufacturing momentum. But in multiplying what was already perfect, it lost the quiet grace of its origin. Imitation without comprehension becomes excess, and excess rarely endures. From the ashes of that contrast comes a timeless truth. True engineering brilliance is not measured in tonnage or output, but in empathy for purpose. The greatest designs are those that answer need with honesty, not prestige. In a world rebuilt from rubble, the Nissen hut stands as a humble reminder that even in war, when urgency rules and resources fade, the mind that listens